Hey there, gang. Welcome back to our bio lecture captures. I know you guys just finished up learning how to analyze a scientific article and take some data out, but we're going to dive right back in to the cell transport unit that we were on. And in fact, today, what we're going to be talking about is facilitated diffusion. And you guys are going to know all about this in just a few minutes. So, first, let's take a quick trip down memory lane. And remember that diffusion, right? It's the process of molecules moving with their concentration gradients, right? From areas of high concentration to areas of low concentration, okay? Diffusion is always going to go high to low, and this is because it doesn't use energy, okay? It's the natural way things in the world move. So passive transport is just another word for diffusion, okay? And this should all be a review. And remember, diffusion is the movement of molecules across the cell membrane without using any energy, okay? So when there's an equal number of molecules on both sides of the cell membrane, we say that equilibrium has been reached, okay? But remember, during equilibrium, right, diffusion still occurs. All right, it doesn't stop even when there's an equal number, right? We see what we have down here on the bottom, where even in equilibrium, we have these molecules that are still going across the cell membrane, and likewise, the molecules on the outside are still moving across the cell membrane, okay? Equilibrium is just when we have the even number. It does not mean that diffusion stops. All right, and then we have four factors that affect the rate of diffusion. If you guys remember the word rate, this just is a fancy word for speed. And the way that I want you guys to remember this, right, we have temperature, we have concentration gradient, we have particle size, and we have distance that something needs to diffuse. Okay? So we have TC, PD. And I'm sure you guys can come up with a whole variety of different ways to remember this in sentences. And that's something you guys can come up with on your own. But TCPD, temperature, concentration gradient, particle size, and distance. A really good way to remember what affects diffusion. Okay, so moving on to what we're going to be talking about today is facilitated diffusion. Okay? Now, I want you to remember small nonpolar molecules. Remember, nonpolar, this is just a fancy way of saying no charge. Okay? These small nonpolar molecules, they pass directly through the cell membrane. Okay? They don't need to be transported via proteins. And if you guys look quickly to the right, you can see exactly this, right? So if I had a bunch of molecules up top here, right, and if they were small and nonpolar, what they'd be able to do is that these molecules could actually finagle themselves right through the cell membrane, no problem, okay? No protein is being used there, right? But what we see sometimes is that we have some large molecules, or we even have some small polar molecules, okay, molecules that wouldn't normally be able to pass through a cell membrane, right? But we see that in certain instances, they're actually able to pass directly through the cell membrane without using energy. So how do they do this? Well, they do this by using proteins that transfer them, okay? And this is the big catch, is that anything that is small and polar or anything that is large can actually pass through the cell membrane, okay, but only through the use of proteins. Okay, and an example of this is if we had a similar cell membrane to what you see above, okay? Right, we have our cell membrane that you see above. Now you guys can see that I actually drew it, right? Okay, if you have that same cell membrane, what we see in facilitated diffusion is that we actually have these protein structures okay, so this is our, what I'd call our, okay, and what they allow for is for molecules that are large, that are small and polar, whatever they might be, oops, we don't want to do that. Okay, they allow these kind of molecules to actually pass through the cell membrane. Okay, whereas they're not able to go directly through, they can go through the cell membrane only through these proteins. Okay, so facilitated diffusion, our formal definition, because I know how much you guys love to have formal definitions, we're going to say that facilitated diffusion, it is the passage of polar and or large molecules through the cell membrane via proteins without using energy. Okay, this is a really fancy way of just saying it is diffusion through proteins. Okay. Also important to note that molecules are going with their concentration gradients again. Okay, so it's literally just like diffusion. But, once again, through proteins. Oops. Okay, so the first transport protein we're going to talk about, so this is number 1, okay? The first transport protein that we're going to talk about are called channel proteins. Okay? Channel proteins are actually open at both ends. Okay, and this is what I mean when I say that they're open on the intracellular and extracellular environment. Okay, they're open at both ends, and they're open at the same time. Okay, so if you take a quick look over here to your right, you can see that right here we actually have a channel protein, which is right here. I'm circling that in yellow. Okay, and you can see that it has an opening there and it has an opening there, right? It's open on both sides at the same exact time. okay? Now, it should also be noted that there are specific channels, okay, for specific molecules. All right, so not just any molecule can go through any channel, okay? Certain cells might only have certain channels for certain molecules, all right? What a channel allows for is molecules to constantly pass through it as if it's a tunnel, okay? The molecules do not bind to the channel, right? They just pass through it. So if you guys look at all of these molecules that we have here, right? Just like a tunnel, they pass directly through this, right? They're never going to actually bind to it, all right? And this is really important because this means that the only factor limiting the rate of diffusion, right, the speed of it, is actually the concentration gradient. Right? So the rate at which the diffusion of a molecule occurs is actually not affected by the protein. And this is because the molecule does not bind. Okay? Basically, a channel protein is just acting like a medium to allow these molecules to constantly pass. So they're only going to be affected by the concentration gradient, the temperature, their size. It has nothing to actually do with the protein channel itself. Okay? Now, our second type of channel transport protein, this is number 2, we call these carrier proteins. Okay? These are only open to one side of the cell membrane at a time. Okay? And if you guys look at this image real quick, you'll see that we have an open slot here facing outwards, right? But this slot here is closed, all right? It's not actually open to the intracellular part of the membrane, okay? And it's not until, right, we see this guy here, he's going in. It's not until this molecule has actually cleared to the other side that we see the second side of that carrier protein open. And you'll note that when the bottom's open, the top part of that carrier protein is actually closed. So what does this exactly mean? Well, in a very similar fashion to channels, okay, there are specific carrier proteins for specific molecules. Okay, so these guys are only going to allow transport of certain molecules across the membrane. All right, now carrier proteins, this is the major difference with channels. Okay, is that carrier proteins individually bind to every molecule they transport across the cell membrane. All right, whereas we initially had our channels, right, they don't actually bind to any of the molecules, right? They just kind of pass through like it's a tunnel. What you guys can see here is that the carrier protein actually binds, right here, to each and every molecule that passes through, okay, until it makes it to the other side and it releases it. All right? So, unlike the channel protein, where the rate of which these molecules is diffused is only dependent on the concentration gradient, The other factor that affects the rate of diffusion is actually the speed of the carrier protein. And once again, this is because these proteins actually bind to every molecule. Okay, think about it. If you have to move a bunch of apples, right? Let's say you have 12 apples to move. You can only move them as fast as you can actually grab them and put them somewhere else. And because you only have two hands and can probably only grab two apples at a time, that's going to affect your speed, right? Whereas if you didn't actually have to grab the apples at all and you could just roll them to where they needed to go, you would probably be able to move them much faster. Okay, so what I want you guys to do is fill this out. All right, let's get all your vocab together, and then you guys actually have a quick assignment to do online, and you'll be good to go for the day. So I really hope you're enjoying this stuff. And with that said, if you have any questions, please just shoot up your hand. Thanks for listening, guys.